Hello. So in this video, we are going to be talking about discontinuities, and in particular, the sort of three key types of discontinuities. So again, continuity and discontinuity are sort of easiest to do at this level with the graphing part. So we're going to be talking about them geometrically. The analytic part is sort of really need calculus to get that part for most of them. There is a bit of a exception here, which is when we talk about rational functions later on, we're going to hit on some of these sort of explicitly in a more analytic context. But before we get there, covering them sort of geometrically at the start, the general idea of what these things are. So first type of discontinuity we're going to be looking at is the whole discontinuity. So whole is this part here, and it tends to be sort of a missing spot, which we will sort of elaborate a little bit more in a minute. The next type, after we do the whole, that's the jump discontinuity, which is so named because we have a jump, right? So we go from one spot down here up to here, right? We have this sort of jump bit here. And the last type that we're going to be sort of looking at, this is called an infinite or sometimes asymptotic discontinuity, and that's because they sort of dip down sort of toward this vertical asymptote or up toward the vertical asymptote. And to be clear, they don't have to go different directions. They could go the same direction, or you could even have it sort of one of them goes in and one of them sort of actually goes to infinity, in which case you sort of talk about it's infinite from that side, these kinds of things. Again, these are things that sort of crop up more in a calculus context. So for right now, what we want to take away is the sort of general form, which we're looking at here. All right, so let's jump into these sort of more in-depth one at a time here. So for whole discontinuities occur because we're missing sort of a specific domain value or some sort of x value, and that generates, right, if we're missing the sort of a, but we have everything near a, that means that we can go sort of all the way up to that point here and all the way over here. Everything works fine, but that one point itself is sort of missing. And so we say we have a whole at this value, right? So the whole is really a point because it's a missing point on the graph as opposed to something like a jump or some sort of asymptotic behavior. And in fact, we usually refer to the whole as being a whole and then the point. So we would say the whole a comma f of a, right? So you'd have something like the whole -2 comma 7 or something like this, depending on what these values actually were, okay? Now, wholes tend to reflect some sort of error in your model, like in your actual sort of mathematical sort of representation that aren't usually there in the actual real life setting that you're trying to model. This is not always the case, sort of rule of thumb, but generally speaking, it's hard to have one missing value in reality but have everything infinitely close sort of work. So usually this is sort of a byproduct of how the math worked out that you tried to use to model the thing, where it sort of works everywhere but this one spot. That's usually what wholes sort of represent. Now next up, looking at jump discontinuities. So jump discontinuities are the situation where we have sort of intuitively, right, we're jumping from one spot to another spot in that same x value. Now here I have an open, right? The open circle means that it's not actually at that value and the closed one is, right? So this is sort of still a function because it passes the vertical line test here. But the important thing is that it sort of gets infinitely close to this bottom value and then suddenly jumps up to this top value. And we represent that by saying that it's sort of going from this point b, right? The b is the x value. So it's going from the point b comma y1 to b comma y2, right, with that same b, where again, we say b comma y1, but technically that's the open circle. That's not actually a point on the graph. We're just getting sort of really close to it, as close as possible until that actual value. So the jump discontinuities, again, sort of exactly what you would sort of intuitively think, it's just a little weird to write down, is when you have this non-zero, obviously, vertical change in that y value at a specific x value, right? Now, typically in sort of a real-world scenario, these jumps represent some sort of benchmark event. So I have here benchmark achievement, but it could, I guess, theoretically be a benchmark sort of failure or something. But it's sort of you hit some threshold that triggers something in the model. So A classic version of this might be like, how many widgets are you going to produce? You're not going to produce sort of 1.5 widgets. You have to produce whole numbers of these things. And so that means you would have to jump from 1 to 2, say. And that's sort of what this ends up looking like. So a classic version of this would be floor function or ceiling functions. These are things with jump discontinuities. But the important thing is that most of the time in the real world, jump discontinuities, even though they're sort of a bad, sort of not very nice thing mathematically, they're very natural in the real world, and it's just because the real world sort of has these discrete things you have to work around. You can't make pi number of things. You have to actually go from one thing to the second thing or whatever. Okay. Last but not least, the infinite or asymptotic discontinuity. So these things are when you have some infinite gap between what's sort of going on between the curves. Again, this is sort of a weird mathematical way of phrasing this because we don't have the actual analytic part that we need from calculus for this part. But again, the idea is that you have some vertical tangent line or some vertical asymptote here, and you're sort of approaching that thing from at least one of these directions. You're sort of going close to it, which means you're going infinitely far down, or you're going close to it and you're going infinitely far up. Again, these things could both go up, both go down. Only one of them does goes up or down, and the other one sort of dead ends into it. That can happen. So these are the sort of infinite asymptotic piece. And again, in the real world, this usually represents some sort of boundary on how good your model is. And this is because, again, in the real world, we usually can't do infinitely sort of large amounts of things or something infinite in reality. So a sort of classic example of this would be the density of a black hole. When you look at the math that represents the density of a black hole, it sort of goes to infinity. But it's sort of debatable whether that's actually a thing that can happen or if that's just what the math is sort of saying, and we're not really sure whether or not that's true or how that could even be true, because having infinite density is sort of a weird concept to have. Okay, so again, typically these infinite or asymptotic discontinuities, these tend to be places where whatever math you're using to represent the real-world event, that sort of is starting to reach the edge of how far you can push the model before it sort of starts falling apart. All right, so what do we do? Well, we talked about the types of discontinuities. We had the whole discontinuity, which is sort of one missing point where sort of whatever reason the math that we're using to model the event sort of doesn't quite work out in that one specific point for some reason, but it sort of works everywhere else. Then we had the jump discontinuity, where we had that sort of going from one finite value to another finite value, but we're sort of jumping between the two. And this is, from a modeling standpoint, usually the most common thing to run into in the real world, because it's actually a very natural thing to have happen, because the real world is not sort of a continuous space in most senses. So, you can only make 3 widgets, then 4 widgets. You can't make pi widgets at a time. This is sort of why you have that thing. And then we talked about the infinite or asymptotic discontinuity. This is usually where we have some sort of boundary on the model. We're really pushing the model to the very edge of what it could represent, and things are starting to fall apart. Okay, so that is that.